When it comes to pandas, I would say that the most important things to know in pandas would be series and data frames. Okay, a data frame is practically just like a table. Okay, it's like your Excel sheet, so like your column and then your rows. Okay, so like your first row will be your column, so like your headers, you get it. Then everything that comes underneath will be your values, right? So in relation to series and data frame, so a data frame would be your table, right? Your table with columns and rows. And a series will refer to one column within your table. So I would say your column name being the name for the series, right? And then your elements within your elements or individual values would be for your series would be the components that come under the column head, your header or your column name in your table, right? So one column, like taking out of your data frame or taking out of your table, is what I would say a series is. So they are very related in that sense. Okay, so we're going to be learning how to create a series and how to create a data frame. In creating a series in pandas, you reference your pandas, right? As we know that we created a short version for it that was PD, so we are referencing our pandas then dot series because we are creating a series. Okay, we have our open brackets, then we want, these are the elements for our series. Okay, then these are the indexes for our series. It's important. Indexing your elements are very important because when you have so much data, so much columns and rows of data, your indexing helps you identify each particular row to work on, okay, or like generally have an overview of your data. If you don't have your indexes in place, you just have your data everywhere and you can't go in there and pick particular data because it has no structure, it has no rules, okay, it has no guidelines, right? So yeah, that's how we create a series. And if we should just reference it, we should see a tiny little series. Right, so yeah, so it's basically just one column, like I said before, just a column within a data frame, right? So let's create our own our own series, so we get so let's just go with data. Okay, is equal to, oh no, it's data in there. Let me just go with ds. Okay, it's equal to, and we are trying to create a series in pandas, so we have to reference pandas, then series, right? Then our open brackets, right? Then we have our elements. In our case, we want to use words, right? So we have yao, we have amma, we have kwame. Okay, and we have our indexes here. We want to give particular indexes to our data, right? So we're going to be giving an index 1, index 2, index 3. Okay, so let me just call it from the jump. So there, that's our series. Is really as simple as that. We have y having an index of 1, amma having the index of 2, kwame having an index of 3. So just one column of a table, right? And as you noticed, your first element here refers to your first index, second element refers to your second index. Okay, so it's just it's relatable like that way. Okay, so our data frame, we learned about dictionaries before. Creating a data frame is kind of making use of that key value pair mentality, okay? Because if you look here, you see name being a key, then this list being our value, okay? So this list consists of 3 names, okay? Age with 3 different elements for so it has to make sense, right? Because you have 3 names, unless you have missing values, each element has to have its corresponding elements in other columns as well, unless we have missing values, okay? So we have 3 names, age having 3 numbers, and then scores also having 3 numbers, right? So here we create a dictionary, like I said, okay, called data. Then we use Pandas DataFrame to create a table from this dictionary that we created here. Okay, so our dictionary has a key value pair having 3 different columns. So this is column 1, column 2, column 3, and these are the different elements that are supposed to populate your rows. Okay, so in creating our data frame, we reference Pandas, because that's where we get that's the library that has data frame within it. So pd.dataframe, then data, then from the dictionary that we created. Okay, so let's run it, and let me just reference df from here. Yeah, we have a table here, okay, 3 columns, then our elements populate our different lists populates the rows as values, right? And we have an auto indexing going over here. So if you don't specify your indexes, it just starts counting from 0 through to whatever number of elements you have, right? So let's create our own data frame as we usually do. Okay, so let's create a data frame. Let me create DT, so data, right? We are just going to be creating 2 columns of for the table. Okay, so we are going to be having food. If you guys have realized, I like food, so food, okay, and then we have a list of foods. So there's a fufu. Why not? My mom loves fufu. Let me see. Let's go with Joff. But why type out the whole thing when you can have the short version? Then right. Then we are going to go on and create a new one. Okay, so another column. Let's just call it prices, right? So like the prices for our food. Okay. And we're going to create a list. Let's say fufu is 50 Ghana. I don't know if that's true. I'm not sure. It's not a string. 50 Ghana. And let's say jollof is 30. Okay. Banku is also like 40. And then we are going to use Pandas to create a data frame, right? So I'm going to call my data frame df1. The df is already taken. Df in reference to data frame, right? The data frame 1 is equal to, so pd being our Pandas, referencing Pandas dots, so data frame, that because that's what we are trying to create. Then it's brackets. Then we'll have to reference where the data is stored. In this case, it's dt. I stored all my data within this this dictionary, and then I stored this dictionary within this variable name. Okay, so we have dt here, and let me just call for it from the jumper. Okay, so this is the the output for our data. Okay, the data frame we just created. We have food and prices, and we have the values populating the rows here, and then the auto-generated indexes beside them. Okay, let's take a look at some properties Pandas has that helps us have a general understanding of our data frames. Mind you, in real life situations, data frames are huge. Okay, they are full of so many rows, like thousands and millions of rows. So it's not like you can just sit there and just be going through each row individually like we were right now, because we have like 3 rows. But in a real life situation, you have so many rows that you cannot go through each individually. Okay, so we are going to be taking through going through some properties Pandas has given us to have easy communication with our data frame and have a sneak peek on general understanding of what our data frame looks like. Okay, so first property we are looking at is .head. You see us referencing df. This is in reference to the data frame that we created over here. So the data frame we created here with data here. Okay, so this is the data frame we are referencing. Okay, so yes, we are trying to find .head of our data frame. Okay, so .head helps us have a sneak peek of like the first few rows of our data frame. Okay, so the top few rows of our data frame is printed out or is given out to us when we use the .head with our brackets command. Okay, so here it displays first few rows. Okay, few rows of our data frame. Okay, of data frame. Okay, that's what this does. So if we should run it, I don't think it would make much of a difference, considering our data frame is like full of just 3 rows. But if we had so many rows, like we have like thousands and millions of rows, that would make sense, because it will show us only the first few rows of our data frame. Okay, let's go on and see try and understand the next one. Okay, so the next property we are looking at is tail. Okay, so tail with our brackets, and as you would assume, this displays the last few rows of your data frame. Okay, so the head takes the first few rows and tail takes the last few rows of your data frame. It displays the last few rows of your data frame. So it displays last few rows of data frame. Okay, that's what it does. Okay, so if I should run it, it wouldn't make much of a difference, because our data frame is literally 3 rows. Okay, it's not going to change. And so let's move to the next. We are looking at shape. We already learned what shape is. Okay, so I'm not going to bore you with it. We're just going to run it so that you see how shape manifests here. Okay, there. As you would think, why does it look like this? Why? Because it has 3 rows, it has 3 columns. Okay, so it's telling us the number of rows and columns here. We have 3 columns, 3 rows. It's not a single dimensional figure, it's a multi-dimensional figure, right? So we have our rows and our columns displayed here, a number of rows and columns here. So as we know, it shows us the number of rows and columns here, as you would expect. So the next thing is df.columns. So df.columns, in a real, as I said, in a real life situation, your data frame is going to be so huge. Your columns are going to be so many. I've worked with data frames where I had like 40 columns. I know it sounds unreal, but yeah, institutions, you have like 40, 30 columns, absurd amounts of columns, right? And you cannot individually be looking for them. In some cases, all your columns are not even printed out to your screen. Okay, so you'd want to see or get a sneak peek of the names or like the elements for each your features for your columns, right? So using dot columns just prints out only the column names here. So this prints out the column names of your data frame. Okay, so if we should run this, we should get the column names for our data frame. Alright, so there we have name, age, and score. These are the column names of our data frame, right? And then it's showing our data type. Okay, it's telling us that generally our data is an object data, because obviously they are words, right? So it's a string data. Okay, so the next property we are looking at is info and describe. Or would I say they are cousins? They give you a general understanding of your data. Okay, describe, even though it usually confuses me, describe helps you. It gives you like a general summary of your the properties of your data. Okay, so we are talking about like the maximum, the minimum, standard deviation. If I've not mixed them up again, that's what describe should do. And info just gives you how do you even say it? The data type, the number of rows and columns. It gives you it tells you whether the number of rows within each column that are populated. Okay, so it helps you easily identify which columns have missing values if I've not mixed them up, of course. So let me try running info first to make sure I don't make a mistake. So yeah, I was right. Total number of columns, entries 3, number of rows, right? From 0 to 2 is the number of indexes. You see, it tells you your data type, and then it gives you a general understanding of the count of each row. So it's telling us that each row has 3 values, right? And they have null values. Okay, there are no null values here. So I was right. It gives us a general understanding of our data, right? And then I'll just here and run it. We have describe, giving us a numeric description, right? A numeric understanding of our data. So we're talking about counts, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, maximum. I'm sure as I'm saying percentile, you're relating to math you learned in basic school. Yes, so this is where it comes to play. Or you always thought it didn't make sense, right? This is where you make use of it. Okay, so your 25 percentile of your data, the 50th percentile of your data, the 75th percentile of your data is generally gives you a math summary of your data frame. Okay. Yeah, so basically, yeah, that's it for exploring our data frame. This is the basics of it. Okay, it helps you just get a general understanding. I usually just run this to get a sneak peek of what I'm working with before I just jump in. You don't want to go head first. You want to see, especially when you're working, to know if you are working with your imbalanced data, if you have null values. You want to see where the data types are not the labeled data types are not actually tallying with your data that is populating your data frame. Okay, you want to have a general understanding of the fault of the data to fix it before you actually start any form of data analysis.